Hello everyone, welcome to PyNet Labs and welcome to the webinar which we are going to conduct today on the verifications of iBGP. So my name is Jatin and I'm working as a Cisco instructor with PyNet Labs. So in this webinar today, I'm going to be your instructor and we will be verifying the iBGP pairing. And also like there is a lot of confusion between the participants and the network engineers that where we exactly have to implement the iBGP and where we have to implement the eBGP and what is the basically difference between the iBGP and eBGP. So a lot of things are there with the BGP itself, but as of now in this webinar today, we are going to talk about implementation of the iBGP and some verifications, like how we are going to verify the iBGP peering is up or not. Apart from that, we will see what is the major purpose behind using the iBGP and what kind of loop prevention mechanism is there, what exactly the neighbor verifications are there. So let's just quickly start with an introduction first of all with the BGP, and then accordingly we will move towards the lab and verify all these topics which are mentioned on the slide, including the lab verifications and the loop prevention mechanism. So this loop prevention mechanism is more about a theoretical concept, but yeah, definitely we will be looking more in detail with the lab verification, that how the loop prevention mechanism is going to come in between with the iBGP peering and neighborship verifications. So first of all, let's just have a quick introduction towards BGP, what exactly the BGP is and how we are going to use BGP. So when I say BGP, so I'll write the heading as introduction to BGP. And when we are talking about the BGP part, BGP is a exterior gateway routing protocol, which is used to make sure that, you are able to communicate outside the AS or with different AS also. So the very first thing about BGP is that BGP is an open standard protocol. It's not a proprietary for any other vendor. So every vendor is allowed to use the BGP. Being an open standard protocol, it also is a exterior gateway routing protocol. So we'll say exterior gateway protocol. So this is one thing. And also apart from that, we can say the BGP is designed to make the communication between different AS. So in simple or sorted, we can say BGP is designed for inter AS domain routing. So we can say design for inter AS domain routing. Now, when I say inter AS domain routing, what does this sentence signifies? What exactly this inter AS domain routing is? For example, let's suppose that you are having one branch office. Let's say this is your site A, and on your site A, this is your site A office. So on the site A, there are two routers which are interconnected with each other. Let's suppose that this is R1, this is R2. On the other end, you are having some site B, let's say different branch office of your organization. And this branch office is again having two routers, router 1 and 2. And let's suppose that this is your AS 65,000 and this is your AS 64,000. And everyone knows that AS is what? It's basically a collection of networks which is under a common administrative domain, or we can say IGP is going to operate within inside the autonomous system. So BGP is always used to make sure that this AS will communicate with this different AS. So in that case, there can be like some implementation of eBGP. In case of iBGP implementation, so depending upon the type of scenarios, it is required where we have to use which type of BGP. But the major purpose of using the BGP is to make sure that we are just making the communication between different autonomous system. And also BGP is a classless routing protocol, which is going to support the features like FLSM subnetting, VLSM, and apart from that, manual and auto summary is also supported. So we'll simply write one point, classless routing protocol. This BGP is a classless routing protocol. And when we say classless routing protocol, that in simple means that it's going to support FLSM, it will support VLSM, as well as it will support auto and manual summary. So this is one thing with the BGP, that it's going to support the auto and manual summary as well. And here in case of BGP, we say that BGP is a path vector protocol. And when we say path vector, what exactly this path vector means, I'll explain you first, then we will move towards the other sections, because this is something a very important aspect in case if we are understanding the BGP. Because understanding the path vector, is a very important thing, because whenever we are verifying the types of routing protocol, so you know that when we are discussing the types of routing protocol, there are two types of routing protocol classified in the category of dynamic routing. In simple, I am writing here. So we are having dynamic routing. So types of routing, when you will see as per your CCNA, CCNP studies, you know that static routing is there, default routing is there, and one of them is a dynamic routing. And this dynamic is associated with some IGP protocols, as well as one of them is your eGP. So eGP is always used to make the communication between different AS. And with this eGP, there is a consideration that we say path vector. And then after path vector, there is a protocol to which we call as BGP. But whereas in the IGP, three different protocols are used. Like we have a categorized chart. We can say distance vector is one of the first protocol which is used. Then we have link state, which is widely used. And then lastly, we have something we consider it as your hybrid. So inside the distance vector, we know that RIP and IGRP are used, whereas in link state, OSPF and ISIS is used. In hybrid, we have eIGRP, which is a combination of both distance vector and link state. So we can say it's equals to hybrid. So this is one thing, but we were on the point, what exactly this path vector is that is associated with this eGP point. So when I say path vector is exactly as such nothing but a method of sending the routes along with the path information. So what I'll be writing here is, I'll write the statement for the path vector, that what exactly this path vector is. So to define this path vector, we can simply say one line that it's a method of sending the route information. So we'll say it's a method of sending the routes along with the path information, that from which particular path it is going to carry the information. So this is one thing. Now let's take one example to understand this path vector behavior. Suppose that, you know, like less hops, or we can say the less number of paths are more preferred, which you will see as per the attributes. It's a kind of section which we have in NRC section. So we basically cover up where we have different attributes. But just for an instance, I'm going to give you one example. If you are having two paths, let's say you have path 1 and you have path 2 inside the BGP topology. So with the path 1, there are some AS values which are associated. So for example, let's suppose that if you are having router 1, you are having router 2, you are having router number 3, 4, and 5, like this. And all these routers are connected with each other. They are forming some BGP relationship. So you know that in case of the updates, for example, this router 1 is having some AS 500, suppose that. Router 4 is having some AS 600, it's having some, let's say 700, like that. So some autonomous system values are assigned 500, 600, and suppose that 800 is there. So in case of, explanation, we can say, just let me write the AS values correctly first to explain you in a clear way. We are having some AS 100 here. Suppose that on router 2, you are having some AS 200. You are having some AS 300 this side. You are having 400. Are having some 500. In case if the router 1 wants to reach on you can say from router 1 to the router number 3. So in that case, the AS path will follow something like this. First of all, the packet is started from AS number 100. Then it will be reaching on the AS 200. Then after that, it's going to reach on the AS 300. So this is one path to send the data from source to destination. Suppose that this is your source and this is going to be your destination, we are assuming. And when the path number 2, the data will originate from the router number 1, which is having the AS value of 100. So I'm directly writing the path, which is basically it will reach on 300 first. Then before reaching on 300, it will reach on 500, then on 400. And this is how the path information will be created. So when it comes to BGP, whenever the BGP is advertising the update, so while advertising the update, whatever the router which is updating, or whichever the router is a part of that particular BGP will also advertise the path information. And this path information is going to carry the information of the AS number. And in this scenario, you can see you are having two different paths. We are having one path as 300, 200, and 100. So in between, there are three AS only. Whereas in this scenario, you are having four AS. So BGP is always going to prefer this path as the best path because it is having less number of AS which it is crossing. So this is one thing. And guys, there might be a chance of loops inside the network, which I'll let you know later on that how exactly the loops can happen inside the BGP. So this is one thing we consider it as the path vector because it is always going to carry the information of the routes along with the path that from wherever the information is being originated. So this is one thing about the BGP path vector. And the next thing about the BGP is the loop prevention mechanism. But that loop prevention mechanism is something that, we will verify that specifically when we will move towards the lab scenario. So as in the previous slide, we were discussing about the BGP. So one more point I just need to add in here about the introduction to BGP, you can say. So I'll write here specifically the point that BGP is a metricless protocol. You know that every protocol is having its own metric. We can say that in case of IGPs, RIP is having hop count, OSPF is having something we call its cost, and eIGRP is having something we consider it as bandwidth using the K values, or we can say a composite combination of four different values. But when we say BGP, BGP is technically a metricless protocol where we don't have any kind of, metric, but instead of that, in case of BGP, we are having some attributes. BGP works with attributes. So this is one thing. And when you will see with the BGP, BGP is classified into two categories that we have some internal BGP and we have some external BGP. External BGP is all about making the communication with different autonomous systems, whereas internal is all about making the communication within the AS. Now, what's the thing with the, eBGP? The eBGP is always going to have the AD value of 20, whereas iBGP is going to have the AD value of 200. So I is for internal updates and E is for external updates. This is one thing about the BGP. Now, when we are going towards the BGP neighborships, like how we are going to define and create the BGP neighborship parameters and how the BGP labs will be implemented. So for that, we need to verify few things first. In case of BGP neighbors, there are two types of BGP neighbors, iBGP and eBGP. Both of them are having different scenarios. So I'll write the heading as BGP neighbors. And when we say the BGP neighbors, these neighbors are classified into two categories, internal and external BGP. And we have eBGP as well. So these are two BGP neighbors which we basically have. And these BGP neighbors are similar to OSPF, eIGRP neighbors, but there are few differences, which are not similar. Like we cannot compare directly with the IGP protocols because these BGP neighbor are, you can say BGP routers who are forming the neighborship. They'll not use any kind of hello messages as of now. They'll be using some TCP connections for exchanging the BGP updates. So we can say the point, BGP neighbors, either it may be your iBGP or your eBGP, are similar to OSPF and eIGRP and any other IGP protocol, but with few differences. And now what are the few differences we have in here about the iBGP and BGP? So these BGP neighbor routers always forms the TCP connections for exchanging the BGP updates. BGP neighbor routers always forms TCP connections using the port number 179 for exchanging the updates. So this is one thing. Now, there are two types of BGP neighborship. We have already discussed iBGP and eBGP, and these BGP neighbors are also considered as BGP peers. So if you heard this term, don't get confused. Now, whenever you are going to see the BGP database, BGP is also going to come up with some database like we have BGP neighbor table. We do have BGP forwarding table and we have BGP routing table. So let's get more in detail about the neighbor table and the routing table and all these things. Then we will see that in the lab section, the verification of this neighbor table. So we'll write the heading as database of BGP. Now with this database of BGP, the very first type of table we have with the BGP is your neighbor table. So this neighbor table is something which is going to have the information of the neighbors. So in case of BGP neighbors, this is a list of all configured BGP neighbors. List of all configured BGP neighbors. See guys, there is a one quick difference when we define the neighbor table statement for IGP protocols. So you guys have seen this thing in many of the scenarios that whenever we are defining the neighbor table of any IGP protocol, which basically means that in case of iBGP or in case of IGP protocols, for example, this is my router 1 and this is my router 2, and both of these routers are configured with some, let's say, OSPF. So you know that in case of OSPF also there is a adjacency table. So AT I'm writing as adjacency table, which in simple means the neighbor table. So here if I'm having .1 and .2 is the IP. So in case of OSPF, the routers are going to exchange the hello messages. And after exchanging the hello messages with the help of the advertisements, they are going to form the neighborship. But in case of BGP, either it is your iBGP or eBGP, be it your any BGP, but the neighborship is something which we have to manually configure in case of BGP. It's not like that we are going to define the commands and advertising all these things. So this is in case of BGP, it's not going to work automatically unless you are not going to configure the neighborship manually. So make sure this point is a very important point, that BGP neighbors are always configured manually, and the network admin or the one who is managing the network is responsible for manipulating the BGP neighbor table. So this is one thing, and neighbors has to be defined manually. I'll add this point. Neighbors needs to be defined manually. So this is one thing, and to verify the neighbor table, there is a command you can use, show IP BGP summary. Show IP BGP summary. So this is one command where you are going to see the list of all configured BGP neighbors. In case of IGP protocols, we write the statement that list of all the directly connected BGP neighbors. But with BGP, we have it's something the manual configurations. Second thing, we have something we call it as your BGP forwarding table. So when we say BGP forwarding table, this is also a very important aspect of the BGP, but this is something which will not be getting more in detail. So then in case of BGP forwarding table, BGP forwarding table is as such nothing, but it's a list of all the networks which is known by BGP along with the paths. So we can say list of all the networks which are known by BGP, whatever the networks you have advertised inside the BGP domain, along with the path information. Because BGP is a path vector protocol. So it's definitely going to carry the path information. So this is one thing. And to verify this, with the path information, as well as you can also verify the attributes with this forwarding table. So attributes plays a big role. So to verify this, there is a command which is show IP BGP. So this is one thing, and routing table is also there, which everyone already knows that. So whenever we are defining the routing table in simple means that the list of the best path to the destination networks. So I'm not going to write the routing table, but yeah, in simple, I can define one point as routing database. So routing table is something you all know that it's always going to have the information about, the best path along with the source to destination, whatever the specific best path is there accordingly. So this is one thing, guys, we have in here about the database of the BGP. Now, on the next end, we are going to see something, which is your configuration and how basically we are going to execute the BGP implementations and inside the real-time enterprise networks. So this is one thing. And apart from that, let's try to see the configuration syntax for BGP, which is same for eBGP and iBGP. So syntax for BGP when we define. So suppose that if you are having two routers, I'll explain you with an example first. You are having router 1 and you are having router number 2. So suppose that this is some WAN interface you are using as, let's say, 20 dot network with /8, and dot 1 is the IP here, and this side you are having dot 2. And suppose that you are also having some networks 172.16.0.10, and on this side you are also having one network 172.17.0.10. So these are two different networks, and as of now, if they are on different AS, assuming that they are on the same AS right now, let's say that they are AS 500. So this is one BGP scenario which I'm assuming right now. Suppose that this is my one AS, and inside this one AS, guys, if you will see that this AS I have given the name as AS 500, where can be multiple routers, where can be different routers, but they needs to be in the same AS. Then only it will be considered as iBGP. But suppose that on one side, this is router number 2 is on the other AS. Suppose that router 1 is on the AS 500 and router number 2 is on 600. So that means it's a different AS. And in case if you want to make the communication of two different AS, then you are definitely going to use the eBGP. So that is the thing between iBGP and eBGP. So as of now, we will be checking with the iBGP. So we are assuming that both of the routers are residing within the same AS. So to configure, let's suppose that on the router 1, the first command you are going to execute is router BGP. And then after executing the command, if you'll put question mark, it's going to ask you for the AS number, like the way we execute in the EIGRP configurations, like router EIGRP and then defining the AS number. In the same way, if you'll put question mark, you will get the values from 1 to 65,535 in here for the AS value. Then second thing we have to execute is the neighbor command. So you will say neighbor, and then here you have to define the neighbor ID, which means to say that, for example, I'm defining for R1. So AS I'm assuming is 500, and neighbor I'll say 20.0.0.2 is my neighbor. Then after defining the neighbor command, you need to say remote AS. This is a keyword you need to add. And on whatever the remote AS your next BGP neighbor is, suppose that this 20.0.0.2 is on AS 500. So you will implement this command remote AS 500. If this is on the second AS, suppose that if it is on the external BGP, so you need to execute 600 in here, depending upon the number of AS. Then the last thing, if you are advertising the network, so you need to say the IP address, the network ID. And then after saying this, you are going to say the remote AS once again, to which remote AS it belongs to. So as of now, then you are going to say the AS number only. So that's how you will be implementing the BGP syntax. And this is what we have in here as a quick introduction for iBGP theory and a basic brief overview, like how basically we are going to execute and implement the BGP section. So this is one thing. Now I'll show you a quick lab where we will be verifying the iBGP parameters and the verifications and the configurations, that how basically we are going to define the iBGP peering. So this is one thing. Let me reshare my lab screen. So guys, I hope my screen is visible to every one of you. And if it is visible, so you can see there are 4 routers which I have taken in. And I am having VIOS 1, VIOS 2, 3, and 4. And all these 4 different routers, I'm assuming that this is some iBGP scenario where all the routers are forming some connectivity within the AS500. So all these routers belongs to AS500. And I'll show you some verifications of BGP loop prevention here, that how BGP avoids loop prevention mechanisms. But as of now, I have already pre-configured some basic things here. Let me just show you. So this is my R1 and enable if I'm gonna run the command show IP protocols. So in the show IP protocols, you can see as of now, nothing is there. If I'll run the command show IP interface brief. So you can see the implementations of basic IP addressing are already being done. On gig 00, I'm having 1.1.1, 01 is having 4.4.2, and 02 is having some 10.1.1. Now, as per the basic IP addressing part, you can see, guys, this 10.1.1, 20.1, 30.1, and 40.1. We are assuming these are the LAN interfaces. And this 1 dot network, 2 dot network, 3 dot network, and this 4 dot network are the WAN interfaces. So first thing is we need to make sure that iBGP peering should be there between all the 4 routers. And the next thing that we need to make sure that all the routes should be able to see the routes coming from the other routers in the routing table through the BGP. So this is one thing. So let's try to implement the router number 1. So as you can see, these are the IP configurations on the router 1. I have already verified you show IP protocols command. No, nothing is there. Only routing protocol application is running up, which is a different thing. No routing protocol is done as of now in here. So I'm going to run a command. I'm going to say router BGP, and if I put question mark, it's asking me for the AS value. So I can use any AS value in between. So as of now, I'm assuming that AS500 is there. Now I'm inside the router mode. I need to define the neighbor command. So after defining the neighbor, so now on the router 1, if you will see, I'm getting 2 neighbors. First is 1.1.2, and this is on the remote AS 500. So this is how we are going to execute the neighborship. And on the other end, I am having one more neighbor, which is 4.4.4.1, which is on the remote AS 500. So this is one thing. The next thing I'm going to use is the network command. Suppose that I'm executing this 10 dot network, and this 10 dot network is subnetted network. So if you'll put question mark, there is a keyword here, network mask. So as of now, I'm using /24, so I can directly execute this network command like this. I'll also execute the 1 dot network. I'll also execute the 4 dot network. Because right now I'm not using any subnetted value. The values which currently I'm using right now is for A class IP, I'm using /8, and for C class, I'm using the default /24. So these commands are being executed in case if you are having a subnetted network. So suppose that you are using some 255.255.224.0. So in case if you are using a subnetted network, then this is the command syntax to advertise the network. But as of now, we don't need that. So I have executed the commands. You can verify. Router BGP 500, I have defined both of the neighbors are forming the neighborship within the same AS 500, and the networks I have executed. So this is one thing. Now, the same implementations I'll be doing on the router number 2, 3, and 4 as well. So we'll move towards the R2. Now with the configs of the router number 2, you can verify first show IP interface brief. So with this brief command, all the IP configs are there. 00 is having 1.2, 01 is having 2.1, and 02 is having 21.1.1. So let's configure router BGP 500. The AS number should be same. In case if you are mismatching the AS number, the neighborship will not come up, and you need to verify with some verification commands in case if you are not using the BGP. AS number is different from one router to another router. So after defining this, you can execute also this command no auto summary. And there is one more command which is basically for no synchronization. This command I'm using because I'm not having a real-time scenario where I'm going to use some switches and PCs. So that is why I'm using this no sync command. Then I'll define the neighborship. Now the neighborship forming with the VIOS2 is one neighbor 1.1.1. And this 1.1.1 is on the remote AS 500. Again, I am having one more neighbor, which is 2.2.2. So now you can see once I executed this command neighbor and I got a log in here that BGP agency of 1.1.1 is up, because on the router one, we have already defined the configuration. So in R1 also you'll find the same log. You can see the BGP neighborship agency is also up. So that's how the manual configuration of BGP neighborship should be there. So this is one thing, and I have executed two neighbors on the router number 2, neighbor 1.1.1 and neighbor 2.2.2. So these are the two neighbors, and execution of the networks will be there now. 20.0.0, 1.0.0, and 2.0.0. Same implementations I'll be putting up on VIOS 3. So this is my VIOS 3, as you can see. Enable configure terminal. And I'm gonna say router BGP 500. And now here, if you will see that I got again two neighbors on my router number 3, which is basically 2.2.1, and the second neighbor is 3.3.2. So these are my neighbors which I'll be executing, but I'll say no auto summary, no synchronization, and I'll say the neighbor command. The neighbor I'm having is 2.2.1 on the remote AS 500. So you will see the log will come up. It's the wrong command, remote AS. Okay. So you will see now a log will be generated for 2.2.1 as well, that the BGP neighborship is up. Meanwhile, I'll define the next neighbor, neighbor 3.3.3.2, and it's on the remote AS 500. So this is one thing. Now also I need to execute the networks. So router BGP, I'm gonna execute the network. I'm having 22 and 3. So I'm gonna say 20.0.0. So this is one, okay, not 20 will be not be there. We are going to see so it's your router number 3. So on the router number 3, we are not having the 20 dot network. So we have 30 dot network. And we will be saying again one more command, which is 2.0.0 network. And we have 3.0 as well. And if you want to verify, you can use a command do show running configs pipe section begin BGP. So with this command, you can see what are the total executions you have executed on BGP. So you can see router BGP 500 command you have executed. Then you have executed 3 networks on VIOS 3, 2, 3, and 30. And 2 neighbors you have defined, 2.2.1 and 3.3.2, which are forming neighborship with the VIOS 3. Now let's implement the neighborship with the VIOS 4 as well, using the same set of commands. And in case, guys, if you are not getting the commands, don't worry. I'll definitely share one lab guide for the same lab, which you can perform at your own by accessing the lab guide. So we have router BGP 500, no auto summary, no synchronization. Then I'm gonna say the neighbor 4.4.4.2 on the remote AS 500. So this is one neighbor. Second neighbor I'm having is 3.3.1 on remote AS 500. So these are two neighbors, 3.1 and 4.2. Let's wait for the log to come up. With 4.2, neighborship is up. And with 3. The neighborship is also up. Now, after defining the neighborship, I'll be implementing the networks. So 40. Network will be advertised. And on the other end, I'll be advertising the 4. Network. Then I'm going to say the 3. Network and exit. So now, as of now, if you will see, guys, that we have configured almost a complete BGP. Now you can see that the BGP neighborship is also up. Let's verify the neighborship now for iBGP. Show IP BGP summary. This was the command which I mentioned to verify the neighbors in case of iBGP if you are using iBGP. So now you can see in this output here that on the router 1, you are getting two neighbors, 1.1.2 and 4.4.1. So 1.1.2 is on the router number 2 and it's on the router number 4.4.1 IP. And this V44 here it is mentioned is the BGP version 4. So if you will see the complete timeline of BGP, you will find that there were a lot of upgradations done in the BGP. There were 3 more different versions priorly before the version 4, but right now in today's enterprise networks, we all are using the BGP version 4 because the BGP version 3 was a classful protocol, whereas this version 4 is a classless, which I have already mentioned. They are forming the AS communication or relation between the AS500. So AS is also mentioned in case if you are using eBGP. So instead of showing you the same AS, it will show you different AS. And these are some logs. But apart from that, in the last, you will see some state and prefixes also there. So this state and prefix is basically all about, verification. So there are various attributes which can be used in case of BGP. So this is one thing. And also you can use one command, show iBGP neighbors, if it is going to work. So you can see a detailed output of all the neighbors you have executed. You will be getting in here, and the remote ID it is using is 20.1.1. The version 4 and the BGP state is established. So there are various other things which you can verify with BGP. So this is one thing. Now, if you will see the router 1 routing table, so I'm going to say show IP route. So in the router 1 routing tables, you will see that the 20 dot network is there and the AD value 200, which is used for iBGP, it is also there. 40 dot network is also there, but I cannot see the 30 dot network in here. But if you will see the configurations of the router number 3, we executed the network 30, right? If you will see the router number 3, see, we executed the 30 dot network command, and it was, we have verified in the running config command as itself. So 30 dot network was advertised. Let's see on the router 2, are we getting or not? I'm going to run the command do show IP route BGP, where I'll only get the BGP routes. So you can see that I'm getting 3 dot network, 4 dot network, 10 and 30. But I'm not getting the 40 dot network. And on the router number 1, the network which I'm missing is the 30 dot network. With VIOS 3, let's verify. Do show IP route BGP. So in here, if you will see that I'm not getting the information of 10 dot network, whereas I'm getting 20 information and 40, 30 will not be getting up in here on the VIOS 3 because itself it has advertised the 30 dot network, which technically means there is a challenge inside the network. Let's verify VIOS 4 routing table. Do show IP route BGP. So in this routing table, you can see 10 and 30 are there, but 20 is not there. So which means that on every router, there is a network which is missing, which in simple means that in the router 1, you are not going to find the 30 dot network C. VIOS 1 verifications, we aren't getting any 30 dot network in the routing entries. And in the router number 4, you will not be getting the network of 20 C. You are not getting 20 dot network advertised. With router 3, you will not be getting the information of the 10 dot network. You can verify in the CLI output of VIOS 3. We are not getting the configs or the routing information of the 10 dot network. So in short, the routes are only sent to the directly connected neighbors, because this is why the BGP split horizon rule is working up in here, because of the loop prevention mechanism. So let me explain you the same thing on my PowerPoint slide first, then I'll explain you the same thing on the notes as well on the lab. So just let me reshare my slides and I'll be showing you the same thing. Now see guys, with BGP, there is a default loop prevention mechanism. So I'll write the heading is loop prevention mechanism. So this default loop prevention mechanism with BGP is there. Like, it's always inside the AS, which is basically, BGP will always carry the AS number and the path information. Based on that, it is always going to deny the internal BGP routes, because, there is a default rule in BGP which says that any update sent by iBGP neighbor. Any update sent by iBGP neighbor should not be sent back to another iBGP neighbor. Should not be sent back to another iBGP neighbor. And that is what happening in our lab because of the default loop prevention mechanism, which mean to say, suppose that you are having some routers. Router 1 is there, router 2 is there, router number 3 is there, and router 4 is there. This is a topology like this we have created on the workspace, and all the routers are connected like this. So suppose that from the router 1, the missing network entry is of 30 network. On the router number 3, you are missing the entry of 10 dot network. On the router 2, you are missing the entry of 40. And on the router number 4, you are missing the 20 dot network. Whereas the exact actual advertised networks are on the router number 1, I'm having some 10 dot network, suppose that. And this side, I'm having some 30 dot network. On router 4, I'm having some 40 dot network. And on the VIOS 2, I'm having some 20 dot network. So these are the actual advertised networks which are there on the workspace. But the red one, which are marked here, the 30, these are the missing routes which are missing from the routing entries. So by default, the router 1 is sending the update to the router number 2. Guys, understand this mechanism because it is all about theoretical explanation first, then I'll verify in the lab section. So as of now, if you will see, the router 1 is sending the update to R2. So as per the default rules, the router number 2 is not allowed to send the same information to the router number 3. In case if the router 2 forwards the same information, like suppose that it is forming inside the same AS, which is AS 500. And you know that BGP is always going to carry the path information, which means to say that router 1 is advertising the update of 10.0.0 to the router number 2. And what router 2 is doing, router 2 is just excluding this update and then forwarding all the other update information to the router 3. So that's why router 3 is not able to receive the 10 dot information, so that in case if one is sending the update, suppose that imagine this router 2 is going to send this information of 10 dot network to the router 3, then the router 3 will also send to router number 4 and the router 4 will forward to router 1. So there can be a chance of loops inside the network like this, because see, this is how the structure is going on. Router 1 is sending the update to 2, 2 is forwarding to 3, 3 will forward to 4, and 4 will forward to 1. So we don't want such kind of loops inside the networks. So to overcome such kind of scenarios, we have two methods, because by default, any update sent by iBGP neighbor will never be sent back to another iBGP neighbor, because iBGP neighborship is all inside the same AS. It's not about the different AS. With different AS, there comes different concepts. So this is one thing. So as of now, router 3 and router 1 are forwarding the information to R4. So just to overcome these loop scenarios, by default, if loop prevention is working, so these are the missing routes that I'm not getting the routing information of 30 dot network on my router number 1. And on the router 3, I'm not getting the information of 10 network. So it's not a relevant thing. So, to overcome these challenges, we have two types of possible options, which can be used in case of iBGP neighborship. So let's talk about those now. The first method is full mesh neighborship. So when we say full mesh neighborship, guys, this full mesh neighborship means in case if you are having 4 routers inside the AS, like the way we have discussed in the lab. So if your router 1 is forming neighborship with R2 and R4, right? Suppose that this is the diagram, router 1, 2, 3, and 4. These are 4 routers which are forming neighborship within the AS. So technically, if you will see, R1 is forming neighborship with R2 and with R4 only. So this is what the neighborship is there. So R1 should also form the neighborship with R3, even though it's not directly connected. And in case of BGP, there is as such no rule that your neighbors needs to be directly connected. So I'll write this point. In case of BGP, there is no rule of directly connected neighbors. There is no rule of directly connected neighbors. Directly connected neighbors. So you can manually configure the neighborship. That's what the advantage you are getting in here. And that not, if they are not directly connected, then how we are going to directly connect them? By using some full mesh neighborship. So we can use some, other commands like this, which we will see in the later on sections. So this is one way of, using the iBGP pairing, using the full mesh. And second one is something which we have is your root reflectors. So that is a different topic. We'll not be talking on the root reflectors right now. So root reflectors are there. So this is an alternate solution to the full mesh neighborship. So to configure the full mesh neighborship right now, we are not getting the roots. You can see I have already shared the same thing with you guys. Let me reshare my lab screen now. So as you can now see the routing entries in the router number one, if I'll again run the command show IP route, and specifically I want to see the BGP routes, you can see I'm not getting the information of the network number 30. So to execute that, it is why it is happening because of the loop prevention mechanism. See, if router 1 is sending this update information of 10, suppose that this is the network which is missing from the router number 3 and 30 dot network is missing from VIOS 1. So if router 1 is advertising this 10 dot network, so it will simply advertise to the VIOS 2. VIOS 2 will see that this information of 10 dot network is coming from the VIOS 1, which is forming inside the AS500. And the default rule says what? Whenever a iBGP neighbor is advertised, it will not send, like whenever an update sent by iBGP neighbor, it will not send back to another iBGP neighbor, which means to say this 10 dot network will not be advertised on the VIOS 3, because if it is advertised on the VIOS 3, there is a strong chance VIOS 3 will forward it to VIOS 4 and VIOS 4 will forward again back to VIOS 1. So it will directly deny that. So that's why it's happening. So to do the alternate solution, just to make the complete information that I should get the 30 dot network in here as well. So I need to configure some other statements here, configure terminal, and I'm going to say router BGP again 500. Already I told you that there is as such no rule that we have to make sure the neighbors are directly connected, but you can define another neighbor. So I'm going to say the neighbor command, and I'm defining the neighbor as 2.2.2, which is this neighbor on gig 00 interface. And then I'll say remote AS 500. So once this command is executed, END if you will write, and on the router number 3 also, you need to execute the same configuration. So I'll write here, enable configure terminal, router BGP 500. The neighbor I'm going to define is 1.1.1 on the remote AS 500 and exit. Now we'll see a log of BGP agency that it's up with 2.2.1 and it's up with 1.1.1. Now you will see we have successfully resolved the loop prevention mechanism. So if you'll run the command show IP route BGP, now you will see that you are getting the information of the 30 dot network, whereas you will also see do show IP route BGP on the VIOS 3. Let's see the previous table. 10 dot network was not there in the VIOS 3, but once I executed this command, still it is not there. So it's going to take some time, but yeah, it will be up. So this is one more thing, guys. And apart from this thing, if you will see one thing, I'm going to take a snip of this diagram and I'll explain you the same thing on the PowerPoint. So let's try to understand this diagram on the PowerPoint slide as per the topology we have used. So this was a diagram which we have executed for the implementation of the iBGP peering. In this scenario, when I connected the neighbors directly, like which are not directly connected. So see one thing, if I am advertising this router number one, so if you are creating the full mesh neighborship, it doesn't means like if you are using this gig 00 interface on this side, and if you are trying to add this network, so you can use any of the networks. So it's not going to work like this. In case of defining the neighborship, you need to take care if you are advertising this gig 00. So then this gig 00 needs to be advertised. If you are using this gig 01, then this gig 01 needs to be advertised. In case if you are checking that on the VIOS2, if you are not getting the information of the 40, so you need to make sure that these interfaces are directly defined for the neighborship commands. Apart from that, if you are defining this side interface on neighborship and on this side you are defining like this, so in that case, it's not going to work perfectly fine. So that is what one thing you guys need to take care of while whenever you are implementing the full mesh neighborship. And full mesh neighborship is a one option. Apart from that, if you want to go with some root reflectors where you can have some servers and clients inside the network, so that too is also possible, but that is not the scenario as of now. And that's how I guess you guys now are able to clear the iBGP pairings and the full mesh neighborship. So this is what we have in here up to the webinar. Now, if anyone is having any doubts and queries related to the iBGP pairing, so feel free to let me know your doubts and queries on the chat box with any of the points we have discussed. Okay, see, we just got one query from Sahil, and Sahil is saying that we want to see the root reflectors. Okay, see, whenever we are defining the root reflectors, so we don't need to go with the full mesh neighborship. Instead of that, what we can execute is that suppose that this is your diagram, and if you are defining root reflectors in there, so what you can define is, suppose that if you are going with root reflectors, you can define this router one as your server, and you can execute all the other devices as your clients. So they will automatically take the addresses, and that's how, like, with help of some you can say some of your client and server configurations, you are going to use the root reflectors in such kind of scenarios where you will be implementing this thing, the root reflectors concept. So it's all about the concept of server and client, where we are going to execute one server, and apart from that other routers will be mentioned, or we have to execute a command for the other routers that they are going to use some command of clients, where we by default use the command that this is a client machine, or on the server you are going to say that, for example, this is your root reflector server, so you will say router BGP 500 no auto summary synchronization, and then you will define the remote AS, like then let's suppose that this is the neighbor you are defining 1.1.2. And then after defining the neighborship command like neighbor 1.1.2, remote AS 500, one more command you will be executing is neighbor 1.1.2. And this is basically your root reflector client. After that, you are going to execute this command. So that's how the root reflector configuration goes on, because root reflector is something which allows the root reflector server to advertise the routes itself to the iBGP peers by using some client server kind of topology, where client updates the server and server updates to all the remaining clients, and all the clients should establish the neighborship with only the server, and not directly the clients will not be able to establish the connectivity. In that case, they need to make sure that a server should be there, and this is always recommended for a large scale enterprise network. And even though in the enterprise networks, if it is a very large scale deployment of BGP, then you are definitely going to see some kind of root reflectors in that. So I hope it's clear, Sahil, or any other doubts and queries if there. So please do let me know. Yeah, Perfect. So that's how we will be executing the route reflectors. And in the upcoming webinars, we are definitely going to cover up the route reflectors and the upcoming things related to the BGP. So that is it, guys, for the webinar today. And apart from that, if anyone is not there in our PyNet Labs Telegram channel, which is like official public group, so I'll be sharing the Telegram group link in your chat box. In case if you are not there, you can join the session, and I'll be sharing one lab guide and all these notes in the Telegram group so that you can access the content which we have discussed in the webinar, and you can save it for your reference as well. So I'm sharing the link to join the Telegram group. You can join in case if you have not joined. So I have shared the Telegram group, guys, and this group I'm sharing the content, the notes, and the lab guide which I mentioned for the iBGP pairing and the neighborship. So you can access the Telegram group in case if you'll find all the resources and content in that group. So that is it, guys, for the webinar today. I hope everyone find it pretty much useful. And in the upcoming webinar, we'll definitely cover a lot of things related to VPNs and the BGP sections. So that is it, guys. Thank you for
Thank you.